All right, in class we ran out of time and I didn't get to numbers 8 and 9. So I'm going to go ahead and do those here in this video. So first of all, I want you to notice on 8 and 9, they look a little bit different than the ones we just solved, which were polynomials and we were finding zeros. In these cases, we still have polynomials, but we're actually trying to find the solutions to an equation. But we're still working with polynomials. 2x cubed plus 9x squared plus 7x minus 6 is a polynomial. And so we're going to use the same techniques we were just using. So first of all, we're expecting to get 3 solutions here, since this polynomial has a degree of 3. Keep in mind, it's possible that some of those could be repeated solutions, or we could say one of the solutions has a multiplicity of 2, for example. At this point, we don't know. Let's go ahead and, first of all, use the rational zeros theorem to figure out what our possible zeros are. So our zeros will be of the form p over q, and p are just factors of 6, and our q's are just factors of 2. So let's go ahead and figure out what our possible zeros are. It's going to be the factors of 6, which would be 1, 2, 3, and 6, over all the possible factors of q, which would be 1 and 2. So basically, we take all of our numerator values over 1, and then all of our numerator values over 2 to figure out all our possible zeros. So first of all, let's do this. And 1, 2, 3, and 6 over 1, that's going to be our first possible solutions. And then if we put each of these over 2, each of the numbers in the numerator over 2, so 1 over 2, that's a half, we don't have that. 2 over 2, that would be 1, we already have 1. 3 over 2, we don't have that one. 6 over 2 is 3, and we already have 3. And so these are all our possible zeros. So now, what I had told you in class is that I'm going to allow you to use the calculator to help you get the first zero. Now keep in mind, if I didn't allow you to do that, you would literally have to do synthetic division with every one of these possible zeros until you found one that worked. Fortunately, you wouldn't have to go very far, but that's how you would do it if you didn't have the calculator at all. So we get on the calculator, and you should get a picture like this when you put that polynomial into your calculator. You just put it in as y equals 2x cubed plus 9x squared plus 7x minus 6. And you get a screen that looks like that if you use Zoom Decimal. And you can see that we have 2 zeros, and you could actually see another one. It looks like it's around a half. Now again, I'm only allowing you to get one of the zeros off of the graphing calculator. So in this case, why don't we go ahead and use -2. So x equals -2 is a solution. Again, we're getting our first solution from the calculator. We know that wherever we have intercepts, those are going to be zeros for the polynomial. So now we're going to do synthetic division with this polynomial using x equals -2. So what we're really doing is dividing by x plus 2. In any case, we're going to have -2 in our box, and then our coefficients are going to be 2. Let's see, 9x squared, so 9, and then 7, and then -6. Notice we don't need to put any zeros in here because we're not skipping any of our powers of x. Go ahead and put your line in there, and we're going to drop the 2. And then remember, we got to multiply, add, multiply, add. So we multiply 2 times -2, we get -4. In our column here, we're going to add 9 and -4, we get 5. Multiply the 5 times -2, you get -10. When you add, you get -3. And when you multiply, you get 6. And finally, when you add, you get 0. And we were expecting a remainder of 0 since we know that this is a 0. Or a solution to this equation. So now we can rewrite this equation in factored form. It'd be x plus 2 times 2x squared plus 5x minus 3 which of course we are getting from right here. We know that since we started with a cubic function and we're dividing by a linear function x plus 2, that our degree is going to drop by 1. So here we start with 2x squared, then 5x, then minus 3. Now as you look at this, it looks like our polynomial here, or our quadratic polynomial, is something that we should be able to factor using the AC method. So let's go ahead and go over here and use the AC method. So here AC is going to be -6 and B is 5. So we need to find two numbers that multiply to -6 and add to 5. They need to have opposite signs, so they multiply to a negative number. And we want to make sure the bigger ones are positive so that when we add we get a positive number. We need 5 here. So let's make our smaller ones numbers negative. So the combination that's going to work is -1 and 6. So let's go ahead and split our b term. We're going to get 2x squared minus x plus 6x minus 3. And then we're just going to factor by grouping. We've got a common factor of x here times 2x minus 1. Of course, we know if we did this right, that our other factor is also going to be 2x minus 1. And you can see to get the 6x there, it's going to have to be a positive 3. Notice 3 times 2x is 6x, and 3 times a minus 1 is the -3. And so when you factor here, you do get 2x minus 1, your common factor, times x plus 3. So let's go back over the left side over here and put this in factored form. And now, you don't have to do this, but I'll just go ahead and do it here. We're going to set each factor equal to 0. Of course, we're going to get -2 there. Here I need to add 1 to both sides and divide by 2. So you get a half. And of course, we're going to get -3 on that last one. So finally, remember we had a degree 3 polynomial. We expected to get 3 solutions. And sure enough, that's exactly what we got. Let's go ahead and move on to number 9. So on number 9, this is going to have a degree of 4. So here we're expecting 4 solutions. And so let's go ahead and look at our possible rational zeros using the rational zeros theorem. So here our P is 13 and our Q is 1. So P would be factors of 13, that would be 1 and 13. The factors of 1, of course, that's just 1, plus or minus 1. And so here we're going to put everything over 1, and so just 1 and 13, the positive and the negative cases are going to be included as possible zeros. So now let's get on to the calculator, and when you put this function, again, you'd put it under y equals x to the 4th, and so on. And you should get a picture like this if you, again, you go into zoom decimal, which would indicate we have a x-intercept at 1, which means x equals 1 is a 0. Again, we're getting that first 0 off the calculator. In fact, that's all we can see in this window. Now, it is possible that if you used a bigger window that maybe 13 or -13 is a 0. But all we needed is 1, and that's all I'm allowing you to get off the calculator. And then now we need to show that it's a 0 and use it to find the other zeros. So let's go ahead and do synthetic division with 1. So let's drop our 1. We're going to multiply, we get 1. Add, you get -5. Multiply, you get -5. 22 minus 5 is 17. Of course, when we multiply, we get 17. -30 and 17 is -13. Times 1, we're going to get -13. And so, of course, when we add, we get 0, which is exactly what we expected. And so now we can write our polynomial in factored form. It'd be x minus 1. That was our divisor. And then that's times the answer that we got here. That'd be x cubed minus 5x plus 17 minus 13. Now, something to keep in mind is, now first of all, look at what we have here, this has got 4 terms, but it doesn't look like something that we could factor by grouping. And so we're going to actually have to do the same process again. But keep in mind, the zeros of the original function are going to be also zeros for this function, other than the one that we already have. And so here's where we have to be a little bit smart. And notice with our graph, because this graph touches or bounces at 1, we know that that's a 0 that's going to have a multiplicity that's even. And so that would indicate there's either 2 or 4 zeros of 1 or factors of x minus 1. And so we're going to do the same thing, synthetic division again, with 1. But this time we're using the other polynomial here. So let's go ahead and do the synthetic division. Let's see, we get 1, or add, and you get -4, multiply, you get -4, add, you get 13, multiply, you get 13, and when you add you do get 0. And so you can see that 1 is a repeated 0, or x plus 1 is a repeated factor for this polynomial. So we can write this as x minus 1 times x minus 1 times x squared minus 4x plus 13, using the answer from our last synthetic division. Now unfortunately, certainly x equals 1 is a 0, that's one that has a multiplicity of 2, which means we should get 2 more solutions, which we'll get from this quadratic equation here. The problem is this thing isn't going to factor. The factors of 13 are just 1 and 13, and there's no way we're going to get that to add to -4. So we're just going to have to set this equal to 0 and use the quadratic formula. Do you remember the quadratic formula? Write it down and then you can check it. So it's x equals -b plus or minus square root of b squared minus 4ac all over 2a. All right, so you're going to get x is the opposite of -4 plus or minus the square root of -4 minus 4 times a, which is 1 here, times c, which is 13, all over 2 times a, 2 times 1 in this case. So -4, that's going to be a positive 4, plus or minus, let's see, we're going to have 16 minus 4 times 13. I think 16 minus 52, you're going to end up with -36 there. And that's all over 2. So let's see, this will become 4 plus or minus. We know the square root of 36 is 6, so the square root of -36 is going to be 6i. This is one where we can pull out the negative, or pull out an I. You could think of it as square root of -1 times square root of 36, and that's I times 6, or 6i. And our denominator here is still 2. So let's break this into 2 fractions. We get 4 over 2 plus or minus 6i over 2. So finally we're going to get 2 plus or minus 3i. So our other 2 zeros are going to be 2 plus 3i and 2 minus 3i. So again, we expected 4 solutions, and since x equals 1 is a repeated solution, it's repeated twice, it has multiplicity 2, you do have 4 solutions here counting the repeated solutions. All right, and that's it for this video.